Welcome back to the Geometric View, episode 48, season 4. Season 5 starts next week, but as for today, we're going to get into the shape of the sounds from the sun.
Oh yeah, get it boy, get it!
How nature and everything that comes out of nature is shapes that originate as sounds from the sun. So the geometry of Earth's radio waves, Earth creates its own radio waves, and these are plasma. I'm Buddy James, your host. Let's get into it. Helicon Physics, let's do this. Let's get into the circuit. The best way to support us is on PayPal, goldenscaling@gmail.com. Thank you. All right, welcome to the Geometric View. Today is 3/7/2021, March 7th. Okay, so we are on, welcome to the Geometric View. Like I said, we are on episode 48, season 4. Today we are going to be getting into shaping the sound of the northern lights, galactic and intergalactic mimicry, the geometry of radio frequencies, and much more. Basically, we're going to be getting into what is the shape of these sounds, these perturbations that are moving through plasma tubes in space here. Let me get a model real quick. I'll be right back. I forgot to grab it. But we're gonna jump deep into what these tetrahedral geometries are and why they're so important, and exactly what it is that they're doing and why they're look like a propeller, and on top of many other things, they're aerodynamic, and they stack, and as we'll see, this is indeed what I'm strive to prove in this episode here, and show everybody else, is that it is this shape indeed that we're about to get into right there that creates these Hissler and Whistler waves and the sound of the northern lights. So it's really the sound of the auroras. We're getting into the geometry of the sound of the auroras. So this is the last episode in season 4, and I'm looking forward to season 5. I see Ramon here is joining us, and I'm grateful to have Ramon here. So anyway, I'm going to share my screen and hop right in on this because there's plenty of stuff that we're going to get into. So let me get my mic here closer to my face and hop right in. Let's see, share the screen. So basically, grab this. The shape of the sounds from the sun is what we're going to be covering. The sound of the sun. That might sound weird or counterintuitive or strange, because it is, but all of nature is different shapes of the sounds from the sun, if you think about it. And yes, the sun is producing sounds, and one of the types of sounds that the sun is producing is an Alfvén wave. Alfvén waves. So the definition of an Alfvén wave is a plasma is a low frequency compared to the ion cyclotron frequency, traveling oscillation of the ions and the magnetic field. The ion's mass density provides the inertia, and the magnetic field line tension provides the restoring force. The wave is dispersionless. Wow. Interesting. So let's look at some of these. these are the longitudinal waves of these Alfvén waves, and we're going to see how light is constructed of these longitudinal waves and how they come into recombination into the atmosphere, into the upper ionosphere, and come pouring down into the Earth as different sounds, frequencies, fractals, and filaments. And that's what I have a presentation that I put together, and of course some maps that I usually always have every week here. So the first thing I want to cover is this little video here. I'm going to make this, open this up, and make this full screen. So how well something works depends on its shape. And these are plasma tubes that we know exist. And I've shown this on a couple of these episodes, but I'm really digging deep and taking a deep dive into the fractal filament and frequency aspect of these tricoidal, tetrahedral types of geometries and shapes. There's so much information that I'm going to be covering, so thank you for being here, and hope you enjoy this this presentation. I just recently started understanding this about a year ago, last February, in episode 9 of the Geometric View. So the Geometric View is on YouTube. It's a YouTube podcast that you're on checking this out. So there's been a long time and a lot of research, at least 18 years of research going into these topics that I'm getting into, these what seem to be heavy terminology laden work, but a lot of it's really simple, and the way that it's broken down, hopefully I can answer questions and be of assistance to help everybody understand this even better. So here, I'm going to play this video. This is from ScienceAlert.com.
Due to its molten iron core, the Earth has a magnetic field around it, just like a bar magnet. This magnetic field extends outwards into space, forming a big bubble that we call the magnetosphere. The inner layer of the magnetosphere, from near the Earth's surface up to 1,000 or so kilometers, is called the ionosphere because it is made up of particles ionized by radiation from the sun. In low-frequency radio astronomy, when we point our telescopes to the sky to measure the faint signals that travel through space to reach us, we need to take structures and perturbations in the ionosphere into account that might change these signals. We need a good understanding of the effects of the ionosphere to make sense of our data. Pictured near the surface, the Earth's magnetic field lines run parallel and come out at an angle to the ground. It has long been postulated that tubular plasma structures go along the magnetic field lines, and into structures like these that can affect our astronomical measurements. Previously, people could only guess what they might look like, since no one has ever been able to image them. My name is Cleo Roy, and I'm an astrophysics student with Castro at the University of Sydney. I have found that we can use a new type of radio telescope to not only detect these plasma tubes in the ionosphere, but to actually image them. And what's more, we can reconstruct their behavior in real time and in 3D. This is a very exciting world's first. The Murchison Wide Field Array, or MWA for short, is a radio telescope in the Western Australian desert. It consists of 128 receiver tiles, spread over a circular area roughly 3 kilometers across, that work together as one instrument. What makes it so special is its huge field of view, letting us observe a large patch of sky and all sorts of celestial objects as they flash or pass overhead. We use the MWA to study how the ionosphere shifts around the observed positions of objects in the sky and distorts them. A good analogy for this is the way lights at the bottom of a swimming pool dance around when the water ripples. We cannot see the water directly because it is transparent, but from the dancing lights we can determine the pattern of the ripples at its surface. Just like when we are looking at an angle down parallel train tracks, if you were standing at the site of the MWA, the Earth's magnetic field lines would appear to converge. What we saw with the MWA was a stunning distortion pattern that strongly coincided with the magnetic field lines. For the first time, we revealed the true nature of these structures as a vast array of plasma tubes, filling the sky in staggering numbers. The MWA's rapid snapshot capabilities allow us to make movies showing the motions over time. But that's not all. The MWA also has the power to see in 3D. When we look at an object, our brain combines the images from our two eyes, allowing us to judge how far away it is. So by analyzing the signals recorded by MWA tiles in the east, separate to tiles in the west, we give the MWA the ability to perceive depth. This has never been done with a radio telescope before. By using the MWA like a pair of eyes, the three-dimensional nature of the tubes springs into reality. We can measure their heights above the ground, see their steep inclination, and watch as they drift sideways towards or away from the MWA. This is a whole new way of looking at the sky.
So this amazes me in many different degrees. First, I want to note the electric eyes, that it takes the parallax of two separate detectors to have the correct vision to see the tubes. I also want to note that these are permanent tubes, well, semi-permanent tubes that are oxygen rich, and ultra low frequencies are moving through them. So the geometry of the frequencies and how they make certain noises is what we're going to get into in this episode. So I wanted to lay this foundation work first, the precursors, or your prerequisites, so we can see that these are real. Then we're going to hear that these are real. Then we're going to see what they're composed of. Then we're going to see the models and how the models have to do with the Dougherty set and many different other discoveries, future discoveries, and how it was also most likely advanced technology to the ancients as well, because there is a really cool disk that we're going to get into, made out of schist, a schist disk, an ancient, let me go to the chat here, and I have some images that I shared. This is just going to be a little bit of a preview, more about what the episode's going to be about, but here's the disk just to show here. That's my new pets. A couple of frogs and beta fish. That's one of the maps for today. This is a video that I'm going to play after, more in a little bit. So I just briefly showed some of those images, but here's the sculptures and here's the shape, and we'll get into the physics, the geometry, the math, and the science, and future thinking, and consciousness, and connectedness, interconnectedness, Lichten flow, the rheology, the rheometry of it, the geometry of flow dynamics of these paths of least resistance as they perturb through space in these tubes. So let me go to the sounds of the Northern Lights. This is a video here, John Casey Films. Looks like I'm not subscribed yet on the geometric view here. So this is really, really cool. I don't know if I should start it from the beginning. It's 7 minutes. Yeah, you know what? I should just start it from the beginning. 7 minutes. Give it 7 minutes. And then we'll come back to the presentation, or you can go after this. But what we want to hear is the sounds of these. We want to hear, I might pause it throughout, or I might skip, but we should probably listen to the whole thing. So here we go.
Earth is constantly bombarded by particles from the sun. When sunspots or a solar flare send enough of these particles toward the Earth's magnetic field, the skies at both poles light up with the aurora borealis and the aurora australis. The particles also create very low-frequency electromagnetic waves, creating a type of natural radio. It can be picked up around the globe with specially designed receivers. So every year around this time, sound recordist Steve McGreevy heads north, where the reception is best, and points his receiver at the sky.
There's just a whole litany of different natural radio sounds to record. Hisslers and growlers and howlers and tweets. It's clusters like a pack of dogs barking. And in the case of this morning, we're having these very soft, hissy whistlers, which are actually fairly rare. It's 5:24 in the morning on Monday, the 22nd of June, 1998 at Larcher Park, Belly River Campground, Southern Alberta, Canada. We've got these great hissy whistlers happening, and in the right channel we're hearing the beginnings of chorus. That was a burst of static from something pretty close, a lightning storm. Oftentimes when I'm recording, you'll hear kind of a and maybe a second or two later you'll hear the electromagnetic pulse from the lightning bolt takes a round trip to the opposite hemisphere, and then it bounces back. And in making this long trip, the frequency components are spread out, so you get this downward falling tone, like a sigh or a hiss. These receivers are sensitive enough that a lightning storm could be happening 1,000 miles away and the static would still be strong. We can just hear all the snapping. Let me turn on this speaker amplifier. You just can't imagine. There is so much. Oh, in fact, we're hearing some nice noises now coming in. Okay, this is a very beautiful sounding event. This is called chorus. Particles from the sun are hitting Earth's magnetic field and generating these noises, probably several thousand miles out in space. Imagine a soap bubble with wind currents pushing against it. You can see it deform. Well, that's essentially what happens with Earth's magnetic field. So yeah, I've got these funky looking triangular shaped loops, 5 turns of about 350 feet of wire hanging up on a tree, picking up the beautiful sounds of Mother Earth. They're just vibrations of electrical and magnetic energy. And so essentially all these receivers do pick up the Earth's radio waves and translate them directly to the same sound frequencies. And so the result is just beautiful and amazing. That's been going on, well, for eons. And they first noticed it in England in about 1882. British telegraph operators started hearing these strange whistling tones in their headphones. But it wasn't until the 1930s when people started associating these with visible northern lights. As electronic equipment became more available to the average experimenter and hobbyist, amateurs started listening to this using fairly crude equipment, maybe a phonograph amplifier connected to a barbed wire fence in the middle of nowhere, similar to what I did when I first heard this myself. When I discovered Earth makes its own radio waves, I was amazed because I'm a nature enthusiast anyway, and always been interested in astronomy and science. I've got a long, quite checkered history with radio, beginning as a little kid playing with an AM pocket radio, tuning in distant stations at night, and I've done all sorts of crazy things, planting radio beacons in the middle of the deserts and bouncing signals off aircraft. And, there's a station in Colorado called WWV, which does nothing but transmit the time 24 hours a day on shortwave.
All terrestrial indices for 21 June follow. Solar flux 102 and Volta A index 16. Repeat solar flux.
But once an hour, WWV lets me know what's going on with the Earth's magnetic field, and they give what we call space weather, which is what's going on in the sun and between the sun and the Earth.
Solar activity was low. The geomagnetic field was quiet to minor storm. The forecast for the next 24 hours.
I'm aware that right now the Earth is in a magnetic storm, and it may be affecting power lines right now. It may be affecting satellites right now. Space weather, this invisible weather we can't really see or feel on Earth, but gee, it's going on out there. And it's wild, and it's stormy at times, and it's calm on other times, just like weather here on Earth. Well, at this very moment, I've got my headphones on. These whistlers are really coming in big streams now. There's just one whistler kind of merging into the other, all slowly descending in pitch. These are so great. Wow.
Steve McGreevy, Canada's Border Peace Park.
So that's that. And that is amazing, if you ask me. And the first time I saw that, I saw visuals, and no, I wasn't on anything. I was actually recording, and I wasn't even recording, no, I heard it, and then I did an episode about it. It's episode 9 in the geometric view. So we saw that these plasma tubes are real. Now we're seeing that the sounds of the northern lights are real, and that now I want to show the geometry of the Earth sounds, because this is Earth's radio waves. This is the ambrosia of the Earth and the sounds of the Earth's reverberation and its resonance. So to keep everything inside of the Schumann cavity, or the Schumann resonance, the Earth always has to ebb and flow and cancel things out and bring new things in to keep things at a certain frequency, the Schumann frequency, the Schumann resonance, which is a series of frequencies from like 7 hertz to 8 hertz, maybe even a little lower. But so here with all that as a precursor, let's get into some space weather, the geometry of space weather, and what these are, and the Helicon physics. This is a presentation that I put together, and I've added a bunch more to it. So we're going to go and zoom through it. You can see this is one of the presentations. Let me present this here. This is one of the presentations that I present we can see these cavitaceous geometries here that we just heard. These in the front that we showed off, the lobed, the trilobe, but it's actually 4 because it has another dimension on the z-axis pushing out, and the y-axis. You can see that as it spirals out, as these sounds spiral out, they this is the tubes. We're hearing the cavitation, the sounds of the cavitations of the geometries coming into contact with the double layers of the tubes. So, and the counter space around this rotation, that actually now would be a good time right before I start this presentation to show here is these videos. We'll get back into the presentation. So the counter space here, and what I was going to show is 2 of these connected, one larger than the other, with string, with yarn, and how they spin when they're connected, creating like a tube. And yeah, so we'll look at the video of those later once we get out of this. Hopefully everything's good on the other end here. Maybe Ramon could give me I can hear you, because my Skype froze up. Okay. There are plasma tubes above the Earth. This image is in front of it. So this is just talking about the whistlers moving through space and how there's new insights to plasma physics and practical plasma technologies and magnetic fields, including plasma thrusters and charged fuel and things that supercharged fuel and things like that. So this is another image here. Let me, since I didn't get a thumbs up from Ramon, let me make sure things are good here on the Skype front. Yep, still recording. All right, good. So let me hop back into the Skype and show this video. This is what I'm talking about. These 2 shapes connected, rotating with counter rotations within subdivisions of counter rotations within. It is nucleated tetrahedral forms of compactification of information into its to these lobes. Each one of these lobes have infinite recursions of counter-rotating charged spheres. There's 5 of them, 1 in the center and 4 on the outside. So you can see it that they rotate like this, and that they create a tube. So these are what I'm presenting as the shape of them and why it's so important inside of the geometry here. All right. So let me go back into the presentation. Whistler waves. Whistler waves are considered a form of helicon waves, or low-frequency electromagnetic waves that travel in a corkscrew-like or hex-like pattern. When helicons interact with plasmas, they exert a pressure or torque on the electrons. The researchers believe that better understanding these properties could someday lead to the design of plasma thrusters for space vehicles. These thrusters use electricity to propel plasma to extremely high speeds, faster than a chemical rocket. So there's the credit there. Helicon. The name helicon was suggested in 1961 by Augrain, for Whistler modes in solid-state plasmas. Shortly thereafter, it was used for Whistler modes in gaseous plasma columns. Whistler wave theory, earlier formulated for plane waves in space plasmas, was adapted for wave propagation in cylindrical geometry, which is still the same today. Helicon waves were found to be useful for producing dense plasmas for applications like plasma processing and propulsion. Excuse me. A large community developed which understood helicons as Whistler modes in radially bounded plasma column propagating axially along the ambient field BO. The dispersion relation in cylindrical coordinates implies that the waves have axial, radial, and azimuthal wave numbers, the later being quantized by integers m. Radial boundary conditions are assumed to produce radial standing waves described by Bessel functions. Wow, that's exactly what it is. Radial standing waves described by Bessel functions. Radial density gradients also affect the mode structure and suggested the existence of other modes, triple piece gold, which is the counter space. The actual Helicon physics is complicated by unexplained wave dampening, different mode excitations, ionization, nonlinearities, neutral gas depletion, double layer formation, diagnostic difficulties, etc., are summarized in a recent review by Shen. So I just wanted to show the topology of it here. The screws of 6 nested and left hand and right hand nested azimuthal wavelengths propagating here. There are 3 azimuthal wavelengths per circumference in phi, and each helix has an additional pitch of 3 wavelengths describing the phase relations with it. That's awesome. So it's all phi. It's phi dampening wells. So here's some more images of this geometry here and how it starts to rotate in columns collected by these pressures. So these are waves with helical phase fronts produced by axial and azimuthal phase propagation. The later forms azimuthal Engine modes of mode number. Okay, so we're going to skip through this. You can read that as you go on, but this is the information that goes along with these images. So I'm just showing these more as visual for right now. You can refer to the other Helicon presentation for more in-depth information about that. All right. So it creates the isosurfaces. Helicon modes and plasmas can also have helical phase fronts, hence angular momentum. The fact that they are bounded column modes is not the cause for their azimuthal propagation. It is the wave excitation with special antennas which rotates the wave phase. Okay, that's what the nodes are, the lobes. In Helicon devices, the antennas are usually external to the plasma and non-rotating. In order to study the waves without the complications of Helicon sources, we have used the large afterglow plasma of uniform density and magnetic fields, absence of boundaries. Internal antennas for excitation of linear waves, which are measured and resolved in 3D space and time. Under these conditions, we can employ linear superposition principles for measured waves and construct the radiation patterns from antenna rays used to excite high-order helicons of both positive and negative modes. First measurements of the phase fronts and wave magnetic field lines have been done. These observations show that helicons defined as Whistler modes with helical phase fronts exist in unbounded plasmas, just like helical electromagnetic waves in free space. It also implies that plasma helicons can exist in space plasmas. Wow. Although Whistler waves were discovered in space plasma, there seems to be no awareness of Whistler modes with angular momentum in space plasma. A few publications mention helicons in space plasmas, but refer to Whistler flux ropes rather than waves with angular momentum. Thus, the field of helicons is wide open in several areas of plasma physics. Some more imagery here. Some more axial alignment and rotation and counter-rotation, the azimuthal properties of spinning. More images, more imagery. We show this a bunch of times. Here's the chorus waves. Here's the magnetosphere way out here. The sun's coming from this way. And you get the chorus waves is where there's a bunch of extra oxygen that wraps around the planet every day. High oxygen that's during the day or the night, one of the two. So here's an example of a helicon plasma thruster, a scientific diagram. Some solenoid power supplies, plasma rocket exhaust, some more plasma engines. Here's some images that I did of the Dougherty set showing that these plasma ropes and these plasma filaments of these helicon mode Bessel function standing waves are interconnected, interlaced, and interrelated. Here's a couple of sculptures that I did, that I created here. Here's another image that helps us understand when there's 6 of them together and how they're rotating and how they're giving off those individual sub-octave, or I guess the individual, I could call it sub-octave, or when you move one magnitude to the next magnitude to the next magnitude, each one of these whistlers or these tailspin off of the whistlers are going to sound different. So based off of the angular momentum and the size, and the dispersion ratio, and if it has 6 or 5 or 3 arms or lobes, it's going to interact differently. The standing waves are going to propagate differently outward, and the standing waves are nodes, and the nodes are all dilating toroids that pull back into the center of the idea in the space of itself as the filament and the fractal and the frequency as it becomes itself. Here's a construction of connecting the nodes of magnetohydrodynamic geometry, the inverse scaling laws, inverse square, inverse scaling laws of geometry that comes off of the sun, and how it breaks down into individual nesting filaments that are harmonic and compose the music of the spheres and the placement of the spheres and their magnetotails, magnetospheres, environments, the placement, whether it has life, whether it has nutrients from the sun, whether it's cut off, and all of the ingredients that comprise the planetoid or the asteroid. So now I want to get into the disk of Cebu. Disk of Cebu, discovered in the tomb of Cebu around 3100 to 3000 BC. I don't think that's when it was discovered, but Pharaoh Enidijib's son, I botched that. Enidijib was the 5th pharaoh of the first dynasty of ancient Egypt. Possible uses: a mixing tool for mixing grains with meat and water and perhaps fruit and other nuts. It is also known as the tri-lobed disc. So it's made of schist, which is extremely delicate and hard to carve without it breaking. So the craftsmanship of this is otherworldly, alien to say least. And this geometry is sitting right in the central hub of the Dougherty set, just like so many other plasma configurations, plasma instabilities, stellar formations, and astronomical configurations are sitting right in the center of the Dougherty set, the Dougherty Network, the Dougherty, the Theodortian roots is how you get these geometries. When you rotate regular polyhedra, it creates charge, and the charge creates different geometries and different Bessel functions, different standing waves that then repeat the standing wave off of that standing wave. It's much similar to a drum and how the sun drums on the heliopause to create the drum beat. Here's an image of, don't mind the cutting here, the bad cutting job. I was just working on creating more images and things. So here's the Dougherty set cut up, and here's the back of that. So you can see the similarities to this disc, which is the disc of Sabu, the tri-lobe disc. Here's some more images of it. Here is what I want to say in the technologies of this is close here. I'll be talking about it, but here's some sculptures that I took directly out of the Dougherty set, and you can see that there is corresponding negative and positive curvature, like an equidistant, equal amount, negative, positive curvature on the piece here, which is really interesting. So 3D Helicon mode structures and sculptures, and we learned about the lobes, and these pulsating lobes is what we were talking about earlier that create the standing waves of the Bessel function, connecting Bessel functions. So here's a little bit about what I might think it is, part of what I think it is here, because nobody knows what it is and what it was used for. So the schist disc, Helicon acoustic resignaling. I think it is entirely possible to create acoustic artificial reality. Using data sets and sonifying them is called sonification. Turning data into sound is sonification. If you could turn the whole Dougherty set and its respective logarithmic spirals and data into sound, it has been my supposition for some time now that that would create some sort of artificial reality or virtual holographic crystal of information that we could see into the past and the future. But anyway, so here it is again, and I highlighted more circles to show that this is how similar this is really crazy. Really, really intense. More plasma ropes having to show off the three-dimensionality of these bounded and wound tetranauts that I will be showing off here. These are the individual quaternion filaments that are created as braids as a result of the helicon mode wave moving through the tubes, creates these types of structures which are very similar to the Native American dream catchers, and we'll see more of that as the compression and rarefaction and the pressure on these tubes open and closes in octaves and suboctaves with the toroidal nodal filamental helical plasma works its way through the system, and paths of least resistance as lightning, as charge, as mycelial networks, as thoughts, as consciousness, as reality, as the streaming flow of now. We'll get into the geometry of now and the taxonomy of the present, which would be interesting. Tetrahelix. So the tetrahelix comes from the Buckminster-Fuller. Here's the tetrahelix. I think it's originally Buckminster-Fuller, but probably formed before him. So this is from Synergetics. Tetrahedral characteristics of chemical bonding. Tetrahelix, chemical bonds as demonstrated by arrangements of tetrahedra. The single-bonded tetrahedron system is like an engineering pinpoint. It can move in any direction. It characterizes the behavior of gases. Okay. The double-bonded tetrahedron system is like an engineering hinge joint. It can rotate about its axis. It characterizes the behavior of liquids. So imagine these lobed imagine charge moving through these tubes, and as it seeks the edges, because charge seeks the edges, it rotates and cavitates and pushes or almost thrusts, or maybe there's no resistance, and their paths that field aligned currents. Maybe there's a field aligned current inside of there and there's no resistance, but there's got to be some, and that's what we're hearing. And so these tetrahedrons are important and would move with similar geometries through 4-dimensional and 5-dimensional space. The triple bonded tetrahedron system is like an engineering fixed point. It is rigid. It demonstrates the behavior of crystalline substances. So you can see a bunch of these tetrahedrons moving through this, and all interconnected with toroidal nodal pinpoints off of the filamental magnetohydrodynamic geometries. All fractality. All of it is phase conjugate. It's golden scaling. It's golden scales of dilating nodes that are pinched and wrapped and rotated and perfectly nested concatenating tubes, cylindrical tubes. So they're counter-rotating also. That's what allows the charge and flow to move through. So the quadrabond and mid-edge coordinate tetrahedron systems demonstrate the super strength of substances such as diamond and the metals. The tetrahelix, a helical array of triple bonded tetrahedra. Here's the tetrahelix again. Geometry, tetrahelix, plural, tetrahelices. So the whole thing is composed of tetrahelices, which is why we're so drawn to these, the Merkaba and the star tetrahedron and so many other configurations that I can't think of right off the top of my dome. Metatron's cube, that's the one I was trying to think of, but geometry, this is the term. Helix formed from linked face to face. That's what it is. So here's a tetra-euhelix linking module, RNA, RNA center, DNA, and there's a bunch more. I could go into this, but there's other episodes that I've done having to do with this, and it gets interesting. The nucleotides. Triplex or tetrahedral DNA. Can DNA exist in a tetrahedral form? DNA can form multi-stranded helices through either folding of one of the two strands or association of 2, 3, or 4 strands of DNA. In 1986, it was demonstrated that a short 15 MER mixed sequence triplex forming oligonucleotide TFO formed a stable specific triple helix DNA complex in 2008. But yeah, it's not common in nature to have the triple DNA. Electroclastic flow, pyro or plasmaclastic flows of helicon waves. You can see this resembles the squatter man here, configuration. Charged balls on the outside. Here's the hourglass, and the squat. But it's also aerodynamic like a yo-yo. And this figure R is figure T, three-dimensional, and figure U in a wireframe. So we have it rotating here inward. Whoops. We have it rotating inward here, and we also see that these diatoms in nature are forming these sequences and these geometries as well, these tetrahedral geometries. So when it collapses in on itself and moves inward and rotates, when two of them rotate like this inward, it creates Saturn. So Saturn is when the two are connected, two lobes to two lobes. I don't see any other figures connected like that. So the opposite of these two, when four are connected, those two. You get X, figure X here, and that's what is like a figure like Saturn, which is really interesting. We also have not really delved into the hexagon on, but we've touched on it in many episodes on the electric view and the geometric view here. So there's so much more happening here with the morphology or rheology and the reality of the plasma configurations as it moves in and out of itself. And here I want to show and highlight that this is scalar. On every scale there exists these harmonies and subharmonies, octaves and suboctave coordinates that allow each different dynamic of these frequencies to create different behaviors that then create different animals here on Earth and different creatures and bacteria and things like that, because it's all connected to the sounds of the sun. This is crazy right here. When you add the filaments and you highlight just one of these, you see that there is, this is the first principal geometry that mitigates the chirality or spin of the helicon mode plasma. The centers of the central spin axis that allows the azimuthal flow of plasma is itself a dampening well of Feigenbaum counter rotation. These right here, Feigenbaum well of counter rotation, which is a branching bifurcation of two and moving in the multiples and octaves of exchange of doubling. So this is quaternion and octonion, and I get ahead of myself. What that means is this is a toroid within a toroid within a toroid. Yes, a simple Bessel function of the standing wave that repeats indefinitely inward on doubling cycles, creating quaternion, octonion, an infinite amount of more filaments within itself as fractal recursions create the frequencies. So yes, this is the geometry of it. this is the proof of it, and you can get so much more in depth here looking at the simple tetrahed. So I like the tetrahed, tetronaut like astronaut versus tetrahed like the knot, like a Celtic knot. But these Celtic knots, and which is my heritage, these are some of the most beautiful, well-defined paths of least resistance of current flow and geometrical design that that I understand, because the whole thing is golden ratio, and so it's golden scaling. So what can be done with this is much needed geometrical engineering for the panopticon to see everything in the universe and to experience it and to create these three-dimensional virtual holographic types of experiences that we can have with the universe of both past, future, and now. Anyway, so this, you can see they're all interlaced and interconnected, and yeah, this is how you turn on and off the individual whistlers. There's the dampening well that I was talking about, repeating Bessel functions. The fractal node goes on and on to create the cascading toroidal forest that comes out from it. So this is all the first gate. This is 0. So this is null. This is stillness, centrality. These are the axial alignments that pull off the pressure into these lobed configurations, as we saw inside the Helicon Physics that we went through. So I hope everybody understands what it is here that I'm showing and displaying, because to me it makes perfect sense. And why this is so important is because this is ultimately a new a new theory of the speciation, a new speciation theory of origin of species of creatures, because it all goes back to the sounds of the sun and the resonance of oh, I think I went too fast and it slowed it down. There we go. So let me get out of that and hop into the news hour, or the news half hour, because we're streaming right along, which is great. Packing this in. Yeah, the geometry of Earth sounds, the geometry of space weather. This is it. Helicon physics. Whistler mode waves. This is all really, really interesting. And I'm glad that I stumbled upon it and I could share with everybody, and hopefully work with like-minded people who want to understand more about this, and technical fields inside of plasma labs, which we're doing, and many other different configurations, aesthetically, artistically, and much more. So let's hop in, if Facebook will allow us to hop in to it. Close out of this. Close out of this. We already witnessed that. So the word of the day, camarilla. Camarilla. A small group of people, especially a group of advisors to a ruler or politician, with a shared, typical nefarious purpose. A military camarilla that has lost any sense of political reality. Camarilla, a group of unofficial, often secret and scheming advisors. Also, a cabal. So that's the random word of the day. we got into the alphane waves. Now we're going to see if Facebook will be so kind to let us in to do the news hour. Here we go. This is great right here. Talk about electric universe geometry. Oh, look at that. The cylindrics within cylindrics within cylindrics with arms that reach out to points of charge, like planetary filaments, Birkeland current, Markland convection, DNA, information, double helical strands. It's just gorgeous. See what it looks like coming back down. Oh yeah. Wow. Very cool. So here's the Mueller fractal, which is what I call it, which is how I've discovered it as researching and looking up space-time fractals. And I also actually found it in the Dougherty set first, and then I was looking for the shapes, and then I discovered it in interscalar.com, interscalar physics. Super awesome stuff. So Hartmut Mueller, great stuff. The common doubling sequence 1, 2, 4, 8, 16, 32, 64, etc., which is the bonding filaments that I was just showing you of the nature, has its application in the vibration realm of music, like we were talking about, the music of the sun, music of the spheres. Visualize a fundamental string of length 1. When we pluck its midpoint, we create the ratio 1 to 2, or an octave. When we half one of those halves, we get a quarter note. When we half one of those quarters, we get an eighth note, etc. This process of continuous halving elicits a beautiful and familiar nesting of sine waves. This was shared from Jane 108, a friend of mine, mathematical wonder, the math magician. This process of continuing halving elicits a beautiful and familiar nesting of sine waves. So like the nesting of the sine waves, like we were showing standing waves in these recursions of these filaments. So generating the infinity symbol or fallen 8, the octavian of vibration, is the key to accessing pathways from the infinitely large or macro galaxy and the infinitely small or micro quantum atomic worlds, like we were saying, octonian, octavian. 8. How they meet is based on the toroidal breadth. How they vibrate is called resonance. How they embrace is called healing. So there's the image inspired by these guys here. There's the link if you want to look more. So more into the looking into the tetra. Perfect timing for Jeremy Pfeiffer and to share this. I want to check that out. That's on there. Universe works like a cosmological neural network, argues a paper, which is sounds about right to me. So bigthink.com, which that's been around, that hypothesis has been around for a long time. Here's into the polar hexagon on Saturn in the Dougherty Network. The predictive framework of the Dougherty set, TDS, suggests that it is the universal projective dynamic geometry of filamentary networks, among other things, meaning all information filaments from one galaxy to another in cosmic power lines called Birkeland currents, and it is done using the supergeometry simplex of the Dougherty set. The Dougherty set exposes the universal scaling rate of growth in organized matter from galactic to subatomic Planck scale, at the dielectric polar base of some birkeland currents lies planetary bodies such as Jupiter, Earth, etc. The hexagon observed in the polar regions can be described as follows, and is inherent in the structure of the Dougherty set. Here's the hexagon. Here's this is a huge picture that I drew, and I tried to take a large, but you can see that due to diachotron instability, these break down. Here's diachotron instability right here. The toroids break down into hexagonal subnested vortexes and vortices, which Aaron showed on the last episode. He was talking about with a video that he shared with the toroids that break up into individual toroids. Now this is what's happening here, the diachotron instability. This toroid moving of plasma or smoke becomes this instability, and then eventually these 6 points, which when you look at this is doing the same thing, but there's a counter rotation, and you can see that the top of the poles, mainly Saturn, the North Pole of Saturn, you can see this hexagonal pattern. Hexagon within hexagon within hexagon within hexagon nested and counter rotating, one moving in one direction, the next moving in the next, which is indicative of a birkeland current, and also showing more proof of the diachotron instability here and the Dougherty set and the carving of the two double layer filaments that create the counter rotation here. One moving in this direction, the next moving in this direction, the next moving in this direction. And these lenses are part and parcel of the essence and the sub-architecture of seeds and plants, and also the sub-nested architecture of cocoons and cocooning. So cocoons and look very similar to all of that. More images of that. So we'll continue on. Oh, look at this. Right after we look at this geometry right here, we see this geometry here. The first known space hurricane pours electron rain. This is an article in Nature, which goes completely against the current models of climate warming, change, global warming. So the first known space hurricane pours electron rain. Satellite observations have revealed an unprecedented space hurricane in Earth upper atmosphere. This was the 26th of February in Space Physics and on the nature.com. Hinting at such events could occur on other planetary bodies. Scientists have previously documented hurricanes in the lower atmosphere of Mars, Jupiter, and Saturn. Similar phenomena have been spotted on the Sun, but the existence of space hurricanes, hurricane-like circulation patterns in planets' upper atmospheres has been uncertain. This person, who I'm going to botch their name, at Shandong University in China, and his colleagues used satellite data to identify a space hurricane over Earth's northern magnetic pole. The event was a whirling pattern, not in air but in plasma, ionized gas that is found throughout the solar system, including the Earth's upper atmosphere. Like its more mundane counterparts, the space plasma had a quiet center, multiple spiral arms, and widespread circulation. It also featured precipitation, but of energetic electrons rather than water droplets. What? That's what I felt. That's literally what I felt one time at this this music concert. And it was raining. I knew it wasn't rain, and I felt this before. Energetic electrons rather than water droplets. Wow. I felt that on 2 or 3 different occasions. breathing, doing really deep breathing and breathing exercises, and induces the atmosphere to create these energetic electrons. The authors found that a 3D model could reproduce the event's main features and explained its formation. Space hurricanes might be universal phenomena at planetary bodies with magnetic fields and plasma across the universe. Wow. Yeah. That's so cool. So I want to know where it happened though. Above what part of the Earth? That'd be interesting to know. Earth people, looking for some blue, looking for some blue. Earth people, this is exactly what happens when the helicons move down a tube. Earth people, moving down a tube, moving down a tube. Earth people, moving down a tube. Everything is tubes, tubular. YouTube's got it right. Everybody's tube. It's their Donnie Darko center plasma coming out of their solar plexus. But this isn't spiraling, it's just opening and rotating. Well, it is rotating, so it creates an illusion of the spiral, which is very similar to the geometry that I was just showing. So, cool. Here's more of that into the plasma filament itself. Here's the dilating spheres moving along the central axis, the field-aligned current, as they do along the Dougherty set, which is really cool, the radiating, dilating toroids. So yeah, Vice is talking about the birkeland currents. That's on the last episode. So we got back caught up with the news. Looks like this is a nice, short, concise episode here. I'll hop back into Skype and start. I'll go into, let's see here, my video, stop sharing my screen, and I'll say goodbye to everybody and do this outro. So yeah, overall the sounds of the cavitations of the geometries coming into existence with the double layers of the tubes. And yeah, this is the geometry of Helicon physics and Whistler mode and Hissler waves and chorus waves, and hopefully we can show how in a few episodes, or maybe one episode, how this creates a scaffolding for life to form off of, for the formative original self-organization of matter to create create the living seeds for formation of the plants, the trees, ocean creatures. Everything is, I believe, all part and parcel out of these filaments, and each filament has its own correlated nucleated center with compactification of this information into atoms, and that the atoms are corresponding with the filaments in the air that are coming from the sun and being fractally recurred around the poles and within the Earth. So that's the Schumann cavity and the Schumann resonance. You heard it here first, folks. Thank you for tuning in to the Geometric View, episode 48, season 4. We'll be back with season 5 next week. Thank you for being here. All out.
I will never fall, I will never be a better person. You can never see me, I can never be inside of that tree, I can never be inside that forest. You wanna see me, but I'm not seeing you. You wanna come where I am, then you cannot. You never off. Nobody get it off. Piece of the pie. If you want a piece of that, you can have a piece of the pie. I'll give you that. I'll give you that much. If you want a piece of this, I'll give you a piece of me. I'm off of your soul. If you want a piece like me. I'll give you a piece of me. I'm off around by the grain of stars. Sometimes it's like some moves you have on every dance floor too. Real smooth, it's like the moves you have on the dance floor. Real smooth, real smooth. If you think you're real smooth on the dance floor, it's real smooth. I like some moves on the dance floor. Christ be in you, Christ be in all, Christ be in God, all of us, be in us as God is in one in all, as one flesh is one flesh. You're real smooth out on the dance floor, dude. You're real smooth out on the dance floor, dude. Real smooth out on the dance floor, dude. Real smooth out on the dance floor, dance floor.
The geometric view is a love is watching product. Love is watching being. Thank you for doing that. Keep your eyeballs out. Pay attention. There's a lot going down this year. Be vigilant. Be mindful. Be insightful. Be loving. Thank you for being here. Thank you for being kind. Share the love. Spread the love. Become the love. Amen. Thank you for joining us in episode 48. See you next week on episode 49, season 5. Have a good week.
life and death. All of us. We have hope. Live your life for the cause. Love life. Live it to the fullest.
As I look at the wall, as I look at your body, can I just see straight through with transparent golden scaling? The largest of the edifice embark on this because this is the journey. The journey is life. Take hold. Here we go. 3, 2, 1. hand shall you wrong passage, shall you chop it off in
Shout loud for the glories of God. Shout loud. Shout loud for the glories of God. Shout loud. Shout loud for the glories of God. Shout loud. Shout loud for the glories of God. Shout loud. Shout loud for the glories of God. Shout loud. Shout loud for the glories of God. Shout loud.
Join us in the fight for Christ, in the fight to save lives. Surprise, submersible, so fast, the first, the last of baptism. Need to say more. Pay attention like the marrow in your bones, zero in your back, arrow in your lungs, zero into the fact, tertiary Christian neurons, synapses and narrow endurance into eternity. I'm a courier, a charismatic attitude, modern meters even meter, it might even be fun. Cider indeed, need nerds, you need nerds, need a virtue, need to be a reason. Feasibility to be a reason to be clean and sober, keys, open doors, signs of directions. Be the carrier of candlesticks, the man who brought you change. Every second you ride into it, you ribbon, you pivot, potential, you curvy cat, could be cold, could be copycat, could be copy corpse, could be Schrodinger's best, could be Michael Racker, Mackie Normo, open-minded, itsy bitsy, freaking huge, a universal supermassive aspect of attached awareness. Aware of this all?
Collaborative consumption.
Are you aware of this all?
Collaborative consumption. The new thing. Consumption. Collaborative consumption. Consumption.
Get up now! Out of the boat! Drop! Where did this up? We don't got about not about a girl, but about a not about a goddess spirit. Get up, what's up? Shut out, chapter. I'm in search of, I'm in earth love, I'm in living life, I'm in living color, I'm in air drop, I'm an earth thing, I'm an earth thing, I'm an earth thing, I'm an earth thing.